sequences. If you don't have one, there's extras. Justin, you good? Or you need one?
No, I got it. I picked them up.
Yeah. Give me a second.
With different types of sequences.
Yep. Need another one out of there in a minute.
It just says different types of sequences.
All right.
You know what's funny
Once you
is
find it.
Robinhood doesn't get stuck in my head anymore. It's not stuck in my head. It's just
I have it.
yeah.
Got it.
It's just there. It's like a muscle. It's like muscle memory for me now.
All right, once you find those notes, go ahead and answer those 4 questions.
I will never stop listening to that. I don't think I will ever stop. Like, I'll be like 70 still listening.
Yeah, let's hope he stops.
I mean, because my uncle has a whistle like that he does. Well, he sometimes listens with it, but like he just does that all the time, just constant. And he's just walking around. You get it. I'm like, oh, Uncle Scott's here. You can hear him whistling.
Oh.
Sorry, that was probably like.
Very recent. But it's all right. You're forgiven.
Am I though? I don't think they're forgiven.
I forgive you.
Ooh.
Favorite function. Well, I did
I
this
got
yesterday. I barely understand it.
Church?
Yeah, you say you want
I just.
Do not go to Damon's church.
I
I
have
had
a problem.
What'd you do?
You did it right, Jen.
Oh, I did do it.
I double checked
Wait,
it.
Really sure.
Wonderful. All right, Emily, you're up.
Oh, you said B, that explains what. Okay. Thank you.
I had to make a color different than mine. Wait, so who's doing part C?
Not really small.
Oh, you want us to do it on the board?
Yeah. Where do you think she?
Okay.
You know the part that she's recording? The part that she's recording?
I am recording.
Actually?
Yeah. I forgot to record first hour because I've been up since 4 o'clock and I didn't have
You
enough
picked
coffee.
the wrong list.
Okay. I'm with that guy so far. Wait, did I get B right?
Pardon
Did
me?
B? Yeah, I got 22, but then I got like negative 27.
Did you get it right?
Was he wrong and I right? Because that could be a pretty good day.
Or D, I got 3.
Yeah, go ahead.
I'll do B. What's 15 minus?
Is he with me?
Yeah,
I think I did it right.
15 minus 7 is not 6, right?
15 minus 7
No,
is
15 minus 7.
15 minus 7 is
8. I was not close.
Which one? I got for F5, I got 8. And then I got. No, I got 5 for that.
Yeah.
First one, 5 for
I was plugging in
Yeah.
like 10 minus 1 for
I
Y.
said, how'd you get decimals? Just go here.
Well, I was taking 10, I was saying like 10 equals 3 and minus 7.
Oh, so you put the 10 in for the F of it? All right, so let's check them all, especially part D.
That's
Part D is right.
exactly what I
I
got.
feel like part D is the easiest.
Really?
We all got
8 was easiest.
Do you think it was the easiest?
8 was.
Well, it's
Why is it weird? Why is it different than the rest of them?
because there's 2 different things.
It's a 2-step.
2 functions.
I mean, B and C were that.
I mean, you know, it's 2 parts.
B and C weren't that
It's
right? What's interesting about B and C?
D, you can put it in parentheses.
The parentheses moves.
I was very confused for a second, and then I was like, oh, that's, it affects it different. It's not, we're not graphing.
Also,
Because I looked at that and I was like, we're not translating, are we? I hope this isn't translating.
No, this is not moving along. I thought part B was interesting the way she worked it, because when I did this, I was like, oh, I already know what f of 10 is, it's just 23, and then subtract 1, but she like did the whole steps. Which is
Well, I did that, but I didn't do the math. I didn't do the math in my head.
You did it.
No, I mean, like, I didn't do the math at all. I wrote it down, and then I was like, oh, it's 23, and then I was like,
Okay, that's fine. It works. Got you to the correct
I just don't want to get counted off for not showing my work.
I would not do that, would I?
Yes.
All right, so now we have 3 different sequences here. I'll let you look at them for a second. And then on your paper in front of you, I want you to write down how you get from one term to the next. You get stuck on the second one, skip it and come back to it.
Oh, you're right. It's weird.
A and C are easy, it's just that way.
Oh, man. That's weird. Go like you, go like I, like the sun.
All right, so part A, what's happening?
I'd say
They're adding 10. That was easy. Part C, that was easy, what's happening? They're multiplying by 2. And if you multiply by the same number, what happens? Or what kind of sequence is it? Geometry.
Oh, I think I have it in my head what we're supposed to be doing, but like, I can't do it.
All right, can we multiply 0 by anything to get 5? So it's not gonna be multiplication, it's gonna be addition, huh? So how much do you add to get from 0 to 5? So
Ten.
5,
You add another 5, so that's.
and then add 10, and then add 15, and then add 20. So aren't you adding 5 more each time?
So how would you write that out?
N plus 5.
Add 5 more each time. Hold on to that, and plus 5, they just sort of that.
Add 5 more to the number you're adding to the number.
Yeah, you can make it as complicated as you want. You're adding 5 more each time.
This has not been the easiest unit all year, but I'm sitting here and I'm like,
Overthinking
I
it.
don't know. Yeah. I was sitting there, I was like, okay. So if you add 5 cubed and then subtract 5
Oh my gosh,
squared
don't do that.
plus 3.
That stresses me out. All right.
Okay.
So if the patterns you described continue, which sequence is gonna have the second greatest value for the 10th term? So don't like continue the sequence right now. Just think about it. Which one of those do you think is gonna have the second greatest value for the 10th term?
A.
A.
No.
Whoa, hang on now.
It's in B.
Is it B?
Yeah.
B's gonna have the second grade.
Yeah, it's gonna be B. No, the second
No,
greatest.
it's gonna be B.
The second greatest is gonna be A.
The highest
Why do you
is
think it's gonna be
C.
B?
Because you're adding 5 to every time on like the 8th turn and R.
Second would be B.
Yeah.
Yeah.
What's the other one?
Well, that's
Why did you say C is
second
gonna be the
greatest
greatest?
term.
Because you keep on multiplying it by 2. It's gonna go 16, 32, 64,
Oh, yeah.
128.
So it's increasing a lot, right?
Yeah.
So part C would be the greatest. You
Uh,
said part B would be the second greatest.
Yeah,
and
no, I
part-
said C, I said
I
C.
said
You said C?
Yeah.
Would be the second greatest?
Yes.
Which is 500
No, no.
Okay.
1,000.
So we are-
But that's what I thought.
We are using our brains, big brains today. We're saying that the second greatest one is gonna be B.
Multiplier.
Okay? Now I want you to find the first 10 terms of all three sequences and figure out if we were correct in our guess.
Well, I know we're correct.
Do you? Did
No,
you prove it
I
yet?
don't. I really don't.
Wrinkle brain, much wrinkle, big good.
6, 7.
I just combined the Jacksepticeye reference with the multiplier reference.
Find the first 10 of each one.
Oh, no. No. I'm not, okay, yes.
Yeah.
My veins popping.
It should be 1, or I mean 2 for sure. I don't know, something like that.
Two. 56. Three.
Which one did you say was second?
Yeah,
I was right at B. You're so smart here.
So smart.
Props to you.
And then you
So-
second guessed yourself.
Yeah.
Alright, so we guessed that B would be the second greatest for the 10th term. Were we right?
Yes.
So it goes in increasing order. Okay, and then which one is geometric? I already said. C is geometric because it multiplies the same number every time. Okay. Now sadly I have to erase all that beautiful math I just did. Okay, done vocab words. Okay, on whatever last day I had you, we talked about geometric sequences. Those are where you multiply the same number every time. If you add the same number every time, it's what's called an arithmetic sequence. It looks like arithmetic,
I was gonna
it's
say.
spelled like arithmetic, it's pronounced arithmetic. I don't know why, mathematicians just like to make life complicated, I think.
Arithmetic.
But for an arithmetic sequence, you add or subtract the same number every time.
The TH even sounds different. Arith.
English is such a fun language, isn't it?
Medic and Matic.
I've met so many
Yeah.
people that English is their second
Did you hire?
language.
It is.
Is that what you're?
All right, I'm gonna read this to you, and then I'll let you look at it and decide what you think. Don't say it out loud.
Ever seen where
Don't say it out
Jacksepticeye is like,
Okay, Jada and I are trying to decide what type of sequence this could be. Jada says, I think the sequence is geometric because in the value column, each row is 3 times the previous row. Mine says, I don't think it's geometric, I graphed it, and it doesn't look geometric. So who do you think is right, Jada or mine? Don't say it out loud, write it on the paper. And explain or show your reasoning. All right, chat with your neighbor about what you said and why.
Yes, you said yours, since you don't know.
mine because it doesn't seem right.
Am I your partner?
Sure.
Mine is right because it doesn't let
It
me.
is.
Well,
Oh
okay, so
my
I-
gosh.
I mean,
I can't really explain it. So 2 is like 6, 2 divided by 6 is 3.
So it makes 6 divided by 2 is 10, yes. Two separate things there. 2 divided by 6 is 1 bit.
And 8 divided by 6, if that's right, is 3. So that wouldn't be right. So it wouldn't be multiplied by 3.
So they're both multiplied by 3, so you say Jada's right.
No, I'm saying that mine is right because it goes from 1, 2 to 5. So the numbers in between, 3 should be 18. So if it was like that, it would.
So for Jada to be correct, this 5 would need to be a 3. Is that what you're saying?
Yes.
Okay. All right, but it's not.
it's a 5.
So why is mine correct?
Because
Those of you that said mine.
It's
Because-
adding 4 each time, so you go 2, plus 4 is 6, plus 4 is 10, 14, 18.
Oh, it's not a 10 or a 14 up there.
You can fill in the term numbers.
Can you?
You just fill them in. They just walk around. 1, 2.
They skipped 3 and 4.
They
So
did.
rude. I'm trying to trick you. So Weston said if you add 4 each time, so the next one should be 10.
10, 14, 18.
So mine is correct. Because the table was wrong. Skip 2 of your terms.
How can they add such complicated things? I was reading that and I was like,
No.
May? 9?
My E.
It has, you get some like super hip stuff where you can put like Justin Bieber in there and like. Thank you, really appreciate it.
Yeah, we really wanted to see Justin Bieber in our math problem.
Their kids or my kids. Right, so arithmetic sequences, add or subtract.
I wonder who's gonna be the next generation's Justin Bieber. Because Justin Bieber was our generation's Michael Jackson. But Michael Jackson was a lot better.
So glad I'm recording this. Same number each time. And then geometric is going to multiply.
And then what's another one?
Same number. Each time. Okay, what do they have in common?
Everything looked like you just stared at.
It's the same number. What else do they have in common? Each time. What are they called if it's arithmetic and geometric?
Sequences.
They're both sequences. And they're both lists of numbers. Okay, so looking back at those first 3 sequences we looked at, I think they're on the front of your paper. Which one of them was an arithmetic sequence? A, because it added 10 each time. Which one of them was geometric? C. What was B?
Combination.
It's called neither, because it's really not either one of them. It adds things, but not the same thing every time. It doesn't multiply either. So that one would be a neither function. Okay, that's gonna go in on page 140, whatever we wrote down at the beginning.
47.
I don't know, whatever page is next.
Back mark 211.
We wrote it down. 146? Yes, that was 146, the writing equations one. So, it's called sequences or functions. And that will go on page 147. Sequences are functions. That's what it says at the top.
Because they are.
I have more organizers than that.
Okay, it's last word.
Are you gonna edit me out of this?
No.
Dang.
All right, so look at this pattern that they have up here. Figure out how you go from step 1 to step 2 to step 3, step 4, and then draw in step 5.
No.
Maybe we must have common interest, so you're like, oh, those videos are hard.
All right. So what do we add between step 1 and step 2?
5 more circles.
Between step 1 and step 2?
Oh,
Yeah.
no, you just add it out there, no.
So you got 3, then you have 4, then you have 5.
You got 6 and 7.
Oh, I think you did. You did?
Yeah.
You did?
You add 1,
You add
you add 1
to the
to.
ones above. So like 3 and 4, so you add 1 each. Yep. So 1, 3, 4, and then row of 5.
You have 1 plus the flavor bug.
Row of 5. That's 4.
So do we add 1 more each time?
We add 1 more.
Well,
to
1
the
plus the
we're
flavor
adding.
above, so
Do we add 1
in
more?
step 1, there's 1 above the next one, so it's 1 plus 1. And 2 is 1 plus 2, 1 plus 3.
Yes.
Mr. Nice.
I don't think it works.
Aw.
Okay, so to go from step 1 to step 2, didn't we add 2?
That's good.
And then from step 2 to step 3, we added 3.
Yeah.
Do you see that pattern also? So is this an arithmetic sequence, since we're adding each time?
But it's not a consistent
It's,
adding of something.
you add 1 each time. It's neither.
Neither.
For it to be an arithmetic sequence, it would be plus 2, plus 2, plus 2, plus 2.
Oh,
okay. Every time, and it's not. Word. Why did I write so much? Okay. Now, using that pattern, it says, what values make sense for n in this situation? Here, n is your step number. Okay, so let's think about this for a second. Are we gonna have negative steps?
No. I
No.
don't know.
Am I gonna have a step 0? Am I gonna have a step 1.5? No. So I'm only gonna have whole numbers, right? So whole number steps. That are greater than or equal to 1. Okay, the values that don't make sense are negatives, or decimals, or 0. Okay. Now we have a table. Let's talk about it. Let's complete complete the table for steps 1 to 5. So step 1, we have 1. Okay, step 2, what does this mean? D of 1.
It's just there.
It's just there. Okay, the D of n talks about the number of dots. Right? So if you
There's
plug in
a-
1 for n, how many steps is that?
One.
That's talking about step 1, right? So for step 1, we have 1 dot. So 1 plus 2 gives us that 3. Okay, so back to this. Okay, this is our answer from step 1. It's the number of dots that we had for step 1. So 1 plus 2 is 3.
Understandable.
So this next one is saying the number of dots we had in step 2, which was 3,
A
right?
lot.
And 3 plus 3 is
6.
6. So for step 4, I'm gonna take the number of dots that I had in step 3 and add how many? 4. The number of dots in step 3 was 6. 6 plus 4 is 10. Are you tracking with me? More, so more. Okay, so for this one, what am I gonna have? D of 4 plus 5. So D of 4 was
This reminds me of a
10,
spreadsheet.
10 plus 5 is 15.
Well, because that's how you do a spreadsheet, is you like click on it and put it on here, and it was like, 3.
Okay, so then it says following the pattern in the table, write an equation for D of n in terms of the previous step and be prepared to explain your reasoning. Okay? So I need to write an equation D of n for any step number n. Okay? So let's look at what we wrote on all of these. So if n is my step number, how do I compare 2 and 1? Or how can I get 1 from 2? We subtract 1. How do I get 2 from 3?
I need words here.
Subtract 1. Subtract 1 and subtract 1 each time, right? So this is gonna be D of that step number minus 1. Thank you. Do you want today's? Yeah. Thank you. You're welcome. It's just I was doing things. Yeah, that's good. Bye guys, have a good day. Bye. Love you. Love you. All right. So now let's look at. Okay, let's look at what we add here. Each time we're adding a number, right? Where does that number come from?
The step.
The step number. Well, what's my step number? 10. So there's my equation for any step n. Okay, so write this down and then explain it to yourself, because later you're gonna be like, I don't know what that means. Okay, so this is the answer to the previous step.
You quit rolling around everywhere.
Sorry.
Plus the step number for the current step number. Okay, I'm not gonna turn the page yet though. Because what did we say about n? Can I have any number ever that I want to for n? No, because not all numbers make sense, right? It
Obviously.
needs to be a whole number that's greater than or equal to
What?
1. Okay, so, where do I write this one? For n greater than or equal to. Okay, but if I take 1 and I plug it in, what happens? What's 1 minus 1?
0.
0. Do I have a step 0?
0 plus 1.
But do I have a step 0? Because this means step 0. No. So I can't start at 1 because then this wouldn't make sense, right? So I need to start for n greater than or equal to 2. And somewhere I need to clarify that step 1 is just 1 dot. Okay, that's what's called a recursive definition. Recursive. So I'll explain this all in another format here in just a second. Okay, a recursive definition is defined using one or more previous terms which are given. Next time we'll learn about explicit definitions. But for today, we're just talking about recursive definitions.
I should remember why I was doing that. But,
All right. This next thing we're going to write down is probably the most important thing to write down this whole unit. So you want to make sure and write it down correctly. So I'm going to give you a minute to write it down, and then I'll explain to you what in the world all of this means. So write all of that down. Okay, so for a recursive definition, each recursive definition has 3 parts. Jack, with me?
Sorry.
Each one has 3 parts. The first part is the first term. It gives you a starting point. If you don't have a starting point for a recursive definition, then you don't know where your sequence starts. You can't use it. Okay? So the first thing on both of them is the first term. Okay, that next thing, G of n and A of n, that's your general rule. So taking that general rule, you can produce the rest of the sequence based on that general rule. And this term right here is talking about the answer to the previous step. I'll call it a step, answer to the previous step. Okay, so it's just like the last one. You took an answer and then you added a number to it, right? So you have to know the one before it to be able to add something to it. And then the last part right here is talking about your domain. What values make sense for whatever variable you have. Typically, it's talking about a variable of n. So every recursive definition has those 3 parts. If it's geometric, the number you multiply by is called your common ratio or your growth factor. I think it was called your growth factor on the homework. For arithmetic, it's called either a common difference or a rate of change. Where else have you heard the term rate of change before?
graph.
What? On a graph? On a graph, yes. What kind of graph?
Monsters.
Exponential.
Moving the monster.
Exponentials were geometric, so that would be a common ratio. Okay? Rate of change. Another phrase for, isn't that, we,
Close.
y equals mx plus b, what does the m stand for?
Rate of change.
Slope or rate of change, yep. Okay, so just guessing, if I were to graph an arithmetic sequence, what shape do you think it would make?
No,
If you're adding the same number every time,
exponential.
it'd be a line.
Line.
Exponential is when you multiply every time.
For arithmetic, it would be.
So an arithmetic function is actually a linear function. And a geometric one is exponential.
So one curves and one doesn't.
Yep. Okay. Everybody has that written down, I hope. If now I've erased it, it's on.
Gone forever.
We already talked about this, if, that first sequence was not geometric or arithmetic, because it wasn't adding or multiplying by the same thing every time. So we're gonna do some of these together, and then I'll let you do some more without me. It says use the first 5 terms of each sequence to say if it is arithmetic, geometric, or neither. And then define the sequence recursively using function notation. Recursively means you have to write down all 3 parts of that recursive definition. So sequence A, what's happening? Should look familiar. They're adding 10 each time. So if they're adding 10 each time, is it arithmetic, geometric, or neither?
Arithmetic.
Arithmetic. Because they're adding 10 each time. All right. So to explain our recursive definition, we have those 3 parts, right? We have to start with our first term. What's the first term of the sequence? 30. Our first term is 30. And then how do I get each term after that? What happens every time? We add a 10. So to find any term in, you take the one before it, n minus 1, and add 10. So there's our second part of our recursive definition. The third part is your domain. For n greater than or equal to 2. Because if you plug in 1, that's a of 0. I don't have an a of 0. I have an a of 1. So I for everything past 1, starting at 2. That's where that came from. Okay, part B, what's happening between each term? It's dividing by 2 or multiplying by half. So is that arithmetic, geometric, or neither?
Geometric.
Geometric. You're multiplying by half. What's our first term? 80. So b of 1 is 80. To get any term b of n, you multiply 1/2 times whatever the answer was for the step before. So 1/2 times b of n minus 1. Last part is the domain, where n is greater than or equal to 2. Okay, try just part C without me. Yep. It's okay, you're on your pencil. You get it wrong.
Have you pulled one of the chains off yet?
This is still today.
Turn off.
I was gonna wait until I was done teaching, but that's okay.
It didn't shrink it enough to pull off with a full more.
I wish.
Just erase a couple of
One, two, three, four. Dang,
How did you wake up this morning?
241, or 741.
41?
Definitely.
It's a big difference there.
741.
Okay,
I did it at 6.
check yours with mine.
Every day,
list.
except for Saturday.
You have 7 on Saturday.
No, 8.
Literally.
Or my dad was.
How'd that go? Pretty good?
Pretty good.
All right, try those last three. D and F.
Rock. They throw this rock and then they scream.
Too
at
good
the
of an
rock.
opportunity.
Okay. All right, part D, arithmetic, geometric, or neither.
Geometry.
Multiply by,
Half.
so it's 1/2.
Pretty.
Hey,
I'm
that's
sorry.
not nice.
I'm used
Is
to
it half?
So your
I talk to all my
first
friends
term
like that.
is
I'm sorry.
Any term after that is 1/2 times the one before it, or n is greater than or equal to 2.
You know what Xbox cards are. Yeah.
Okay, part E, arithmetic or geometric or neither.
Arithmetic.
You got things.
Arithmetic.
Arithmetic.
Start at 1. Nope, your first term is 20, sorry. Each term after that is the one before it minus 7. Okay,
How'd that work out for you?
and the last one, is it arithmetic, geometric, or neither? Neither.
Either.
The sequence should look familiar because it's the one we found with that tower game that we played last time, right? Our first term is 1. How do you get from one term to the next?
Multiply 2.
And then multiply by 2 and then add 1, right? So times 2 plus 1. So you multiply 2 times the answer before it, and then add 1. When n is greater than or equal to 2. Okay. One thing I want to point out is that sometimes, instead of saying that the first one, or the first step is 1, they will call this f of 0, giving that like your starting point. And if they do that, if this is f of 0, then your domain over here would be greater than or equal to 1. Whatever this number is, it's always 1 more than whatever you have right there. So just know it's not always 1, sometimes it's 0. So if you see that, don't panic. That is all, folks.